Assalamualaikum warahmatullahi wabarakatuh. So today, me and my group are going to provide a little presentation called Newton's Law of Cooling and Warming. So Newton's Law of Cooling states that the rate at which the temperature T changes in a cooling body is proportional to the difference between the temperature T in the body and the constant temperature TO of the surrounding medium. Alright, so from the formula d capital T over dt equals to K multiplied by T minus Ts, where T is the temperature of the object at time T and Ts is the constant temperature of the surroundings. K is a positive constant that depends on the characteristics of the object and its environment, and d capital T over dt is the rate change of the temperature within time.
Okay, so for our problem statement. It was a noon on a cold December day in Kundasang and the temperature was 16 degrees Celsius. Detective Lee arrived at the crime scene to find a murder victim lying on the floor. He found that the temperature of the body was 34.5 degrees Celsius. 1 hour later, a second measurement showed that the temperature of the body was 33.7 degrees Celsius. Determine the time of death. Assume that the normal body temperature is 37 degrees Celsius.
Every problem have its own solution, so based on our problem statement, we can solve it by using the mathematical models of Newton's law of cooling, which is d temperature divided by d times equals to K in bracket of T minus Ts. Ts is temperature surroundings, T is the temperature we want to find, and K is a constant of proportionality. So this equation is the base to solve our problems. But first and foremost, we need to find few information, which is temperature surroundings, initial temperature, and the temperature at the given times, which is in our case is equal to 1. So our temperature surroundings is 16 Celsius, initial temperature is 34.5 Celsius, and the temperature at the given time, which is T1, is equals to 33.7 Celsius. Subtract the information into our mathematical equation. We will get d big T divided by d small t equals to K in bracket T minus 16. So first of all, we need to separate both variables, which is the temperature variables into the left and the variables time into the right. Then we integrate both sides. We will get ln in bracket T minus 16 equals to KT plus C. Then to find C, we will using the initial temperature, which is equal to 0. The temperature is 34.5. Subtract the information, we will get 34.5 equals to CE in power of K0 plus 16. Then we will get C is equals to 18.5. Next, when we already find C, we need to find our constant of proportionality, which is K. So we will be using the temperature at a given time, which is equal to 1. The temperature is equals to 33.7. Subtract the information into the latest equation, which contain the C. Then we will get 33.7 equals to 18.5 E in the power of K1 plus 16. Then solve it, we will get K is equals to negative 0.442. Then subtract the value of K into the latest equation. We will get T equals to 18.5 E in the power of negative 0.442 T plus 16. Then this is the equation to solve our problems. So to find the time of death, the given temperature is 37 Celsius. So subtract it into our equation. Then we will get 37 equals to 18.5 E negative 0.442 T plus 16. Solve it, we will get negative 2.94 hours. Then we will find the time of death by 12 PM minus 2.94 hours. We will get 9.6 AM. This is the time of the person's death.
It can be concluded that the Newton law of cooling is very important for understanding thermal process in various applications. such as in the natural cooling of objects, temperature control in engineering, and forensic science. The law shows that cooling occurs faster when the temperature difference between an object and its surrounding is large, and the rate of temperature change decreases as the object approaches the ambient temperature. However, it assumes that the ambient temperature remains constant and does not take into account other factors, such as radiation or phase change, which might be important in more complex scenarios.